Now let us start with the spherical coordinate system. Here earlier we have studied about cylindrical coordinate system. So what are the coordinates in cylindrical coordinate system? They are rho, phi, z are the coordinates in cylindrical coordinate system. Okay. So similarly in spherical coordinate system, the coordinates are r, theta and phi. Okay. Here if you observe these two, so what is the common coordinate in a cylindrical and spherical? So phi is the common coordinate or same coordinate in cylindrical and spherical. Okay. You know what is the meaning of phi? Phi is nothing but a horizontal angle made with x-axis. Okay. So this is same in a Cartesian and also in it is same in cylindrical and also in the spherical coordinate system. Okay. So what are the new coordinates here? R and theta. Okay. So here let me explain what is r and what is theta here. So to explain r coordinate, first I am going to consider r is equal to constant. So here you know that one coordinate constant always represents a plane or surface. Here r is equal to constant is a surface. It is a surface. So let me explain what is r is equal to constant surface. Here r is equal to constant is a surface of a sphere. Just consider coordinates. Here I am going to show you only a small portion of the sphere. I am not going to show you entire sphere. I will show only a small part or small portion of the sphere. Okay. Yeah. So here this is the small part of the sphere which is present only in the first quadrant. Okay. So here the center of the sphere is at origin and radius of the sphere is nothing but r is the radius of the sphere. Then the entire surface or total surface of the sphere is called r is equal to constant surface. So simply r is equal to constant represents surface of a sphere. When radius of the sphere is r and the center of the sphere is nothing but origin. Okay. So here in the three-dimensional, I cannot show you this three-dimensional sphere here. That's why I have shown you only a small portion of the sphere. Okay. So but you have to assume that entire sphere you can assume. Okay. So here if you consider any sphere, what is the front view of the sphere? In the front view, sphere looks like a circle. Okay. What is the top view of the sphere? In the top view, sphere looks like a circle again. Okay. From any side or from any direction, sphere looks like a circle. Okay. So here I am going to consider what is the front view for this one. Front view. So to write the front view, first of all, you tell me what is the front view of this coordinate axis. In the coordinate axis in the front view, we can observe YZ plane. Okay. So in the front view, we can observe YZ plane. This is y axis and this is z axis. And I am going to draw here the negative y axis and negative z axis. Yeah. So x axis is outwards the board or outwards the paper. Yeah. Now just see here. Here in the front view, a sphere looks like a circle, isn't it? So I'll draw the circle here. It is not a circle actually, it is a front view of the sphere. So here the center of the sphere is nothing but origin and the radius of the sphere is nothing but r. Then the entire surface, the total surface of the sphere is called r is equal to constant surface. R is equal to constant surface. Okay. So now just observe this one. Here from these two diagrams I am going to explain about what are the 3 points about r coordinate. Okay. So first point, what is mean by r? What is r represents? Okay. If you observe this one, generally you say r is the radius of the sphere, but sphere radius is measured with reference to center of the sphere. What is the center of the sphere? Center of the sphere is origin. Okay. So the r is a radial distance from the origin, or r is a perpendicular distance from the origin. Okay. So simply r represents a radial distance from the origin. A radial distance from the origin. And you know that origin is a point. So I call this one as a reference point. A reference point. Okay. So simply we say that r is a radial distance from a reference point. That reference point is nothing but origin. Okay. Or center of the sphere. Second point. What is the range of r coordinate? I said r is a radius. R radius is a radial distance or simply distance. Okay. Distance or radius both are positive values. So r is a positive value. So what is the range of positive values? 0 to infinite. Okay. So r coordinate ranges from 0 to infinite. Next. Third point. What is AR cap? Okay. So here as usually we know that for any unit vector we say that AR cap is increasing r direction. Increasing r direction is AR cap. So this is nothing but increasing r direction. Increasing r direction is AR cap. Okay. Now let us examine here. So whenever r value starts from the origin, at the origin r value is 0. When we move away from the origin, r value is going to increase like 1, 2, 3, 4 like this. Okay. So here we say that this increasing r direction is nothing but AR cap. Is nothing but AR cap. Okay. Now if you observe AR cap, this is moving radially away from the origin. So we define AR cap as the direction radially away from the origin or direction radially away from the reference point is called as AR cap. Okay. So we define here AR cap is nothing but direction or the direction radially away from the origin. Radially away from the origin. The origin is nothing but reference point. A reference point. The direction radially away from the origin or reference point is nothing but AR cap. Okay. That means in electromagnetic fields, whenever we have any physical parameter that is moving radially away from a reference point, then its direction is represented with AR cap. Okay. Example, you just consider electric field due to positive charge. Okay. What is the direction of electric field due to positive charge? Always electric field moves away from the positive charge in all the direction. Yeah. Like this. Okay. So whenever any physical quantity that is moving radially away from the reference point is nothing but AR cap direction. So the direction of this physical quantity is nothing but AR cap. Yeah. Or we can say some another example like a light emitted from the bulb. Okay. Let us consider any bulb here. Consider bulb. Yeah. What is the direction of light from the bulb? So light will emit the bulb. That light will move away from the or perpendicularly away from the surface of the bulb like this. Okay. So whenever you observe this light direction, so the light looks like moving away from center of the bulb. So all this light looks like the moving away from the center of the bulb. What is the center of the bulb? Center of the bulb is a point. It is a reference point. Okay. So whenever any physical quantity that is moving radially away from a reference point, then its direction is nothing but air cap. Okay. So here the direction of this light emitted from the bulb is nothing but air cap. This air cap. Okay. So like this, in electromagnetic fields, whenever we get a situation that if any physical quantity is moving radially away from a reference point, then its direction should be air cap. Okay. So this is about r coordinate. Okay. Next we will see what is meant by coordinate theta. Then consider theta coordinate. So first let us consider what is theta is equal to constant. We know that again one coordinate constant is a plane or surface. Here theta is equal to constant is a surface. Is a surface. Okay. So now let's consider coordinate axis. So here theta is equal to constant is nothing but surface of a cone. Consider this cone. Here z axis is the axis of the cone. Axis of the cone. And the origin is nothing but vertex of the cone. Vertex of the cone. And here we consider theta is a cone angle. Cone angle. Okay. So for this cone, the entire surface of the cone is called as a theta is equal to constant surface. Okay. So here consider entire surface of this cone. This complete cone surface is called theta is equal to constant surface. So that means theta constant represents surface of a cone when cone angle is theta and cone axis is z axis and vertex of the cone is nothing but origin. Okay. So here to better understand this theta is equal to constant surface, let us sketch the few diagrams. Okay. I consider sketch theta is equal to 0. Theta is equal to 45 and theta is equal to 90, theta is equal to 135 and theta is equal to 180. Let us sketch this theta is equal to constant surfaces. Okay. So for that let us consider coordinate axis. Yeah. So this is origin here. This is origin. So first let me tell you what is a theta is equal to 0. What is meant by theta is equal to 0? Theta 0 is a cone surface when cone angle is 0. Okay. What happens when this cone angle becomes 0? When the cone angle becomes 0, this cone surface will coincide with cone axis. Okay. Then the cone angle will become 0. So that means for theta is equal to 0, cone will coincide with z axis. Okay. This is theta is equal to 0 or theta 0 is nothing but positive z axis. Is nothing but positive z axis. Similarly, consider next one theta is equal to 45. Okay. Theta is equal to 45 indicates it is a surface of a cone when cone angle is nothing but 45 degrees. Okay. So consider a cone here. Yeah. So here cone angle is nothing but 45 degrees. Okay. Then the entire surface of this cone, total surface of this cone is called theta is equal to 45 surface. Theta is equal to 45 surface. Okay. So then next one, what is meant by theta is equal to 90? So theta is equal to 90 means the cone angle is 90 degrees for that cone. Here this cone angle, that the angle between cone surface and cone axis must be 90 degrees. Okay. So cone axis fixed one, there is z axis. Okay. Z axis makes 90 degrees with which one? Z axis makes 90 degrees with xy plane. Okay. So whenever cone angle is 45 degrees, cone surface will coincide with xy plane. Okay. Where you can observe 90 degrees. This is the 90 degrees. So this cone surface makes 90 degrees with cone axis. Okay. So this is called as a theta is equal to 90 surface. If you observe here, this cone surface is coinciding with the xy plane. That's why theta 90 is also called as xy plane. It is xy plane. Okay. Next one. Consider theta is equal to 135. So here theta 135 means it should move beyond 90 degrees. Then cone will become an inverted cone. So angle made with this cone axis or positive z axis is 135 degrees. Then the total surface of this cone is called theta is equal to 135 surface. Is 135 surface. Okay. Now in this case a cone will become inverted cone. So next consider last one, theta is equal to 180. That means a cone angle is 180. This cone surface should make 180 degrees with z axis. Okay. Which makes 180 degrees with z axis. So definitely negative z axis makes 180 degrees with positive z axis. So that means this cone surface will coincide with negative z axis. Then the cone angle is nothing but 180 degrees. Okay. So theta 180 is nothing but negative x axis. Is nothing but negative z axis. Yeah. So these are the different theta is equal to constant surfaces. Okay. So now observe this one. Here we have a cone here. So what is the front view of any cone? When you see here, this is the cone surface. So consider what is the front view. In the front view, cone looks like a triangle. In the front view, cone looks like a triangle. And you can see cone axis and cone angle is nothing but theta. Okay. Similarly, what is the top view of this cone? If you see from the top, we can see the circle of the cone. So top view. In the top view, cone looks like a circle and you can see the vertex. Okay. So this is the front view and top view of this, the cone diagram. So I would like to know what is the front view of this entire diagram. We have seen here theta 0 to theta 180, different types of theta is equal to constant surfaces. I would like to know what is the front view of this entire diagram. Okay. You know that in the front view, the cones looks like a triangles. Okay. So let me explain that. Consider the front view of this entire diagram. Yeah. So first of all, let us know what is the front view of this coordinate axis. Okay. So what is the front view of this coordinate axis? In the front view, you can observe YZ plane. Okay. So this is Y axis, Z axis, negative Y axis, negative Z axis. Okay, is the front view. So here is the X axis, that is outwards the board or outwards the paper. Okay. So just consider theta is equal to constant surface. Okay. Here already we have observed that theta constant indicates a positive Z axis. Okay. In the front view, positive z-axis looks same. There is no change. Okay. So this is theta is equal to 0. So next consider theta is equal to 45. Theta 45 is a cone here. So in the front view, cone looks like a triangle. Okay. So here the cone looks like a triangle, where cone angle is 45 degrees. So this is called as theta is equal to 45. Then next one, theta is equal to 90. Theta is equal to 90 is a flat sheet or a flat surface which will coincide with the xy plane. Okay. So in the front view, this xy plane looks like a horizontal line. XY plane looks like a horizontal line. Yeah. So where you can observe cone angle is nothing but 90 degrees. Then the plane will coincide with XY plane. In the front view, XY plane looks like a horizontal line. Okay. Next, similarly, consider this inverted cone where it is a theta is equal to 135 surface. Okay. So here in the front view, this cone looks like a inverted triangle. Okay. So this cone looks like an inverted triangle where this cone angle is nothing but 135 degrees. So it is called as a theta is equal to 135 surface. Okay. Similarly, the last one is theta is 180. Theta 180 is a line coinciding with negative z-axis, or simply it is a negative z-axis. Okay. So it looks as it is. So which is theta is equal to 180 degrees. Okay. So now whenever you observe this one, when theta value is increasing, from 0 to 180, how a point is moving on the cone. Okay. You consider any point on the cone moves along the curved path. And if you complete this one, it looks like a circular path. Okay. So this is the curve. Theta value will increase if you move away from z-axis. Okay. So now by observing these two diagrams, let me explain what are the three important points about coordinate theta. Okay. First point, what is theta? So you know that theta is an angle. So here theta is an angle means we should exactly define is theta is a vertical angle or it is a horizontal angle. Okay. Where you can observe here, it is vertically downwards. Okay. When theta value increases, it is vertically downwards. So it is making vertical angle with z-axis. Okay. So we are going to say that theta is vertical or elevation or lookup angle. Lookup angle made with z-axis. Okay. The simply theta is a vertical angle or elevation angle or lookup angle made with z-axis. It is the first point. Next, secondly, consider what is the range of theta. Yeah, here in these two diagrams, you can observe that theta value starts with 0 and ends at 180 degrees. Okay, so theta ranges from 0 to 180, or you can say that 0 to pi radians. This is the range of theta coordinate. Okay, so next consider third one and very important point. Eighth recap, unit vector for theta coordinate. Okay. So in general explanation, you know that any unit vector direction is given by increasing theta direction is the eighth recap direction. So we say that increasing theta direction is eighth recap. Okay. So then let us observe when theta increases, how we can sketch the direction of theta. Okay. So whenever we start from theta is equal to 0, when theta increases, observe any point on the cone. If you observe any point on the cone, while theta is increasing, it is moving along the curved path. Okay? Whenever any object is moving along the curved path, how do we find its direction? So we need to draw a tangent for this curve wherever we require direction of theta. Okay? So observe this one. Here, whenever you want the theta direction at this point, the theta increasing path is like this. Okay? So draw the tangent for this one. This is a recap direction at this point. Similarly, if you want theta direction at this point, draw the tangent along the increasing theta direction. There is a recap direction at this point. Similarly, we consider this point. We need a recap direction at this point. So draw the tangent for increasing theta curve. That is the recap direction. Okay. So wherever you require theta direction, draw the tangent for increasing theta curve. That gives recap direction. Okay. So on the another side, here also when theta value increases, this point on the cone is moving like this. So in this direction, in this side, if you want theta direction here, you draw the tangent again here. Like this, wherever you require theta direction, draw the tangent for increasing theta. Increasing theta curve. Okay. So now whenever you observe this one, how do we define from this diagram? How do we define what is theta cap from this diagram? Okay. So here, whenever you observe this one, all these are tangents. The tangents, all these tangents are around this center point. This center point is nothing but origin. Okay. So generally cone is expanding like this. Just you can observe in this diagram. Whenever cone starts at this point, it is expanded like this and expanded to the maximum and is going to shrink towards the negative z axis and completely coincide with the negative z axis. Okay. This entire cone is moving around this vertex of the cone. Here vertex of the cone is nothing but origin. Okay. So whenever cone moves around this origin or vertex of the cone, then these tangents also possible only around this origin, around the origin. Okay. So we can explain a theta cap like this. A theta cap represents increasing theta direction as tangents around origin. Actually, origin is nothing but a vertex of the cone, or it is a reference point. Okay. So this origin is nothing but vertex of the cone or it is nothing but a reference point. Reference point. Okay. So this is about theta coordinate. So till now we have studied about what is a r coordinate and what is a theta coordinate. Okay. So and third coordinate is phi coordinate. We already know what is meant by phi coordinate. Okay. So this is about spherical coordinates r, theta and phi. Okay. So we have studied coordinates in spherical coordinate system. We know what is meant by r, what is theta and what is phi. Phi already we have covered in cylindrical coordinate system. Okay. Now we know all the coordinates in spherical coordinate system. What is theta, r, theta and phi coordinates. Okay. So here, next consider differential length element. Differential length element. dl bar in spherical coordinate system. Here, you know that length element is a one-dimensional region. Okay. So, one-dimensional region means one coordinate is required to construct the one-dimensional region. Okay. So, that means here differential length element is constructed with r coordinate or with a theta coordinate or with a phi coordinate. Okay. So here I will take plus or minus common here. So r is directly length or distance. Okay. So then what is the differential length due to r? dr is the differential length. Okay. And direction is nothing but plus or minus ER cap, where I have taken plus or minus common, or length may be due to theta. So here, you know that theta is an angle, it is not a length actually. So we need to convert angle into length, okay. So then we have to write the differential length element. So for that, let us consider the coordinate axis. Consider this coordinate axis. Here consider any random point in the free space, okay. So this is the point. So in spherical coordinate system, any point is represented with r, theta and phi. So first, can you tell me what is meant by r? R is a radial distance from the origin. So for this point, radial distance from the origin is nothing but r. And what is the theta? Theta is a vertical angle made with z-axis, okay. So vertical angle made with z-axis is theta. So now just observe this one. So here, when I increase theta by a differential amount, then what is the differential length element? That's what we need to find out, okay. So let us consider, I am going to increase this theta by a small amount or by a differential amount. Increase the theta by a small amount d theta, okay. So initially the point is at location 1. I consider after increasing this theta by differential value d theta, point has moved to second location. So then the point moves along the curved path. So we know that what is the length of an arc or what is the length of a curve. So here length of this curve is given by, so the length of this arm or length of this side is nothing but r, and angle made by this arc or curve is nothing but d theta. So r d theta is the length of this curve or arc length. So here we can observe that, so a differential change in theta is a d theta. So d theta is a differential angle which will produce a differential length of r d theta, okay. So we say that theta will produce a differential length of r into theta, okay, where we have converted the differential angle into differential length, okay. And what is the direction? E3 cap. E3 cap is the direction, okay. Or what is the length due to phi coordinate, okay. Once again you observe this one, this coordinate phi is an angle or length, phi coordinate is an angle, okay. So this angle we have to convert into length. For that, once again consider coordinate axis, yeah. Coordinate axis, yeah. So again I am going to consider a random point anywhere, this is the random point, and the radial distance from the origin is nothing but r, and vertical angle made with z-axis is theta, okay. Now to represent a horizontal angle made with x-axis, that is phi, okay, I am going to consider the projection of this line onto the xy plane, okay. Let us consider projection of this line onto the xy plane like this, okay. So this is the projection of this length r. Now you can show that what is the horizontal angle made with x-axis, this is phi here, okay. So initially point is at location 1, this point is located at r units from the origin, with making theta vertical angle with z-axis and making phi horizontal angle with x-axis, okay. So this is the way how we can represent a point with r, theta and phi, okay. So now I will draw a parallel line for this one. Here is the parallel line, okay. So length of this line and this line both are same, and you know that here this line is exactly on xy plane. So if this line is on xy plane, what is the angle made with z-axis? 90 degrees, okay. Similarly these two are parallel lines, so this line also makes 90 degrees with the z-axis, okay. This is fine. Now what we need to understand is, if you increase phi value by a differential amount or small amount, how much length will be generated, or how much differential length will be generated. That's what we need to find. Okay. So let me increase the phi value by a differential amount or small amount. Increase this phi value a small amount or a differential amount. Okay. Then this projection moves from one location to another location. Okay. Similarly, actual point also moves from one location to another location along the curved path. This is location 2. So here projection of point 2 is shown here, which we can say 2 dash is a projection of 2, and this is 1 dash, which is projection of 1 here. Okay. So now just observe this one. Whenever I increase phi by a small amount d phi, a curved length is formed. So this is the curved length and this is the projection. Now I would like to know how much length point has been displaced or moved. That will give you differential length. Okay. For that, to find this differential length, we know that this angle is nothing but d phi. Angle is d phi. And what is the length of this side? We need to know what is the length of this side. Okay. Or this side. To find what is the length of this side, okay, I am going to consider this triangle separately. Triangle, origin 1, I consider this point is P. O1P is the triangle that I would like to consider separately. Okay. So just see this triangle. This is Z axis and this is the origin. This is 1.1 and this is the length L, which is perpendicular to Z axis. This is L. And this radial distance from the origin to point 1 is nothing but R. And this vertical angle is nothing but theta. Okay. So just I have replaced this triangle, rewritten this triangle here. Okay. So just observe this triangle. From this triangle, can you tell me what is the sine theta? Sine theta is nothing but L by R. Okay. I write sine theta is equal to L by R. From this one, what is L? From this diagram, from this equation, L is nothing but R into sine theta. That's it. So we obtain what is the length of L is nothing but R sine theta. Okay. Then can you tell me what is this arc length? Here angle made by this arc is d phi and the length of this side we have moved is L. Then this arc length is nothing but L into d phi. But what is the L? L is nothing but R sin theta and multiplied with d phi. Okay. Simply what you can understand here is, if you change the phi value by a differential amount d phi, okay, this d phi will produce a differential length of R sin theta into d phi. Okay. So here you need to understand the differential length due to d phi is nothing but R sin theta into d phi. So I write here R sin theta into d phi. Direction is a phi cap. That's it. Okay. So this is the differential length element in the spherical coordinate system. It is very, very important to understand in the spherical coordinate system. Okay. So from this entire discussion, we need to understand an important point is that in spherical coordinate system, coordinate R will produce a differential length dr. But theta is an angle, theta will produce a differential length of r d theta. Okay. And phi is also an angle which will produce a differential length of r sin theta into d phi. Okay. So like this. So length due to all the three coordinates in spherical coordinate system. Okay. This is very, very important to understand in spherical coordinate system. Okay. So once if you understand differential length due to r, theta and phi are total differential length element, then you can easily write down what is meant by differential surface element and what is a differential volume element in the spherical coordinate system. Okay. Now let us write down what is a differential surface element and differential volume element in spherical coordinate system. So now consider differential surface element. So we know that surface elements are two-dimensional regions. Okay. So they are two-dimensional regions must be constructed with two coordinates, combination of any two coordinates in spherical coordinate system. Okay. So here ds bar is given by, so surface element, first I will take plus or minus common, the differential surface element with the combination of r and theta, or surface element with the combination of theta and phi, or with the combination of phi and r. Okay. So now just tell me, differential surface element contains area of the surface into direction of the surface. Okay. What is the differential area due to r and theta? R will produce a differential length dr. Theta will produce a differential length of r d theta. And what is the direction of the surface? So here surface is constructed with r and theta, and the direction will be in the remaining coordinate direction. What is the remaining coordinate? Phi. So a phi cap. R. Next, differential surface element with theta and phi. Theta will produce a differential length of r d theta. Phi will produce a differential length of r sin theta d phi. And direction of the surface will be in the remaining coordinate direction. Remaining coordinate is r cap. R length due to this phi coordinate is r sin theta d phi, and differential length due to r coordinate is dr, and surface direction is remaining coordinate direction, that is a theta. Okay. So now just rewrite this one. So now differential surface elements in spherical coordinate system are here r dr d theta into a phi cap, or r square sin theta d theta d phi into r cap, or r sin theta d phi dr into a theta cap. So this is the way how we can write down differential surface elements in spherical coordinate system. Okay. Similarly, let us write down what is a differential volume element. Let us write down differential volume element. dV. Here volume element is a three-dimensional region. Volume is a three-dimensional region. That means a volume must be constructed with all the three coordinates. Okay. So here the coordinates r and theta and phi. So then what is the volume element dV? R will produce a differential length dr. Theta will produce a differential length r d theta. Phi will produce a differential length r sin theta into d phi. Okay. So finally differential volume element in spherical coordinate system is r square sin theta dr d theta and d phi. So this is the differential volume element in spherical coordinate system. Okay. So this is the way how we can write down differential length element, surface element and volume elements in spherical coordinate system. Once you can write down, if you are able to write differential length element, surface element and volume element in all the coordinate system, that is in Cartesian, cylindrical and spherical, then you can perform this line integral, surface integral and volume integral for any kind of vector. That may be vector in Cartesian, vector in cylindrical and also vector in spherical coordinate system. Okay. So this is about a spherical coordinate system. So this is the end of the coordinate system. Okay. Here till now we have completed two basics. One is a vector calculus. Okay. Next one is a coordinate system. Okay. So here after completion of this coordinate system, we need to understand how to write gradient, divergence, curl in different coordinate system. Already we have studied about the gradient, divergence and curl operation, but we have studied only in Cartesian coordinate system. But you should be able to write all these formulas in any coordinate system. For that I am going to explain a procedure called as general formulae. From that you can write down any formula in any coordinate system. Okay.